numbers. Oh, I don't like seeing myself. Get out of the way. What do you notice about sine theta and cos theta? So what do you notice about the two patterns? Yep. Yeah, they're opposites of each other. So that is actually deliberate. So they are opposite. And the way, what I mean by that, it's probably not the best word to use, but if you have a look at the pattern, sine theta goes from 0 to 1 and cos theta goes from 1 to 0. So they basically essentially go in opposite directions is probably a better way to describe it. And then tan theta is a world of its own. Okay. So yeah, the ratios in sine increase and the ratios in cos decrease. And then tan just continually increases, actually. It's always a continuous increase. Now, from here, let's do some estimating. So you will learn later how to do it exactly, but it says find an angle theta that satisfies these conditions. So we'll do a rough estimate. If sine theta here is 0.454, where does the angle have to lie? Between which angles? 0.454. In my list up here, where is it? It'll be between 15 to 30. So guesstimate, it's got to be closer to 30 because it's 454. So anyway, I'll give you the exact answer. It's about 27 degrees. Okay. Sorry? Oh, so see how it says 4.54? So 4.54 lies between 15 degrees to 30 degrees. Sine 15 degrees to sine 30 degrees. So it's an estimate. We're just estimating, right? So 0.454 is somewhere here. Oh, okay. Okay, guys. Yeah. Okay. Now, next one, guys. Can we stop the background talking, please? This is time to listen. If you have a question, pop your hand up because a lot of people will probably have the same question. Now, cos theta 0.588. So, what degrees or angles does that lie between? So, cos theta 0.588. Yeah, it'll be somewhere between 45 degrees to 60, probably closer to the 60 degrees. So the exact answer for this, theta is actually 53 degrees. Okay? So just getting you to look at the scale and roughly where it should sit. And then the 9.514, I totally understand that you will not know this one, but this one is about 84 degrees. Okay? It really increases a lot. So, oh, sorry, it's gone off the screen. 84 degrees. Okay, so now that you know how to use your calculator, can you please evaluate those three values for me, please? So sine 50 degrees, cos 16, and tan 77. I'll ask in a minute. So to 2 decimal places this time. Okay, cool. So sine 50 degrees, yep. Yep, so good. Just do control enter. Yep. Because you know how they're opposites, so it tells you the opposite. Yeah. Okay, so sine 50 degrees, somebody?
0.76.
Was there?
Oh, 7.
Yeah, what was the third?
No, 6.
6, so it'll be 7. Yep. So 0.77.
Wait, I don't get why we round it.
It just says the question because it asked you. Yeah. Then cos 16 degrees, 0.96. Thank you very much. And tan 77, 4.3. Sorry, 3. Okay, thank you. Okay, good. All right. So as long as that's just evaluating the values. of the ratios. Now, example 2, it says find the value of x in the equation cos 20 degrees equals x over 3, correct to 2 decimal places. So I'm just going to write it out a bit bigger here so I can write it around it, is x over 3. So now this is like solving an equation, but the thing is with cos, you treat cos 20 degrees as one entity. So don't split up cos and 20. That always stays together. So essentially cos 20 is like a letter. Just pretend it's like y or x or something like that. Okay, so it's its own thing. I've seen people split up the letters. It's one thing. Okay, so cos 20 degrees is its one thing. Now, if I want to solve it, I want to get x by itself. What do I need to do to both sides to solve it? Divide. I want x by itself. So we've got x divided by 3 here. What's the opposite of dividing? Times by 3. Okay. So what you will end up with is, and I'll just write it out, 3 times cos 20 degrees is equal to x. Can you put that in your calculator? So 3 times cos 20 degrees. And you need to make sure you put in the times. So 3 times cos 20. Now, sometimes your calculator will compensate for your lack of times, but I'd always just get in the habit of doing it, okay? Because sometimes it does weird stuff if you don't do it. So control enter. So we'll get 2 point, and how many decimal places? 2. So 2.82. Oh, I've got off the screen, haven't I? Yeah. 2.82. Okay. So yeah, treat cos 20 degrees like it's a letter, it's a thing by itself.
Is that degrees or just?
No, just 2.82. Yeah. Yeah, because it's the value of the ratio. So cos 20 will essentially be 2.82 over 3. That's what that's showing. Okay, good. Over the page. So this is where you'll see use of all what you've just done just then and yesterday come out. All that hard work comes to fruition by being able to solve these kinds of things. So it says for each triangle, find the value of x correct to 2 decimal places. So first thing we need to do is write a ratio. Okay, so we've got our angle. What's my x going to be labelled as? Opposite. What's my 7 going to be labelled as? Hypotenuse. Going back to SOHCAHTOA. Which ratio do I need to use for this first one? Sine. So sine, I'll write the whole thing out. Sine theta is opposite over hypotenuse. So I'll just start by writing what it is. Then we substitute all the bits in. So sine, my degrees is 38. 38 degrees is equal to, opposite in this case is x, hypotenuse 7. Okay, so then from here, what do I need to do to both sides? Times by 7. So x, I'm just going to, actually no, I'll leave it. Oh no, go back. 7 times sine 38 is what I was doing, right? I'll just show the step on this one more time. Because I don't expect you to use these things anymore. Times 7, just so you know what's going on. So times 7. So 7 times sine 38 degrees is equal to x. Okay, plug that in. I have worked it out in advance. And so I got. It will make 4.31. Okay. So I would expect you to set out at least the ratio substituted in. That middle step where you show 7 times sine 38 and then the answer. You don't have to show that top one, but I do it the first few times just so you get used to what you need to write out. All right, so the second one, line there. So this one, same deal. Need to label all my sides. So we've got 42 degrees. What's my x going to be? Opposite. Good. For? Adjacent. Great. So which ratio? TOA. Good. So tan theta is equal to opposite over adjacent. Substitute your values in. Tan 42 degrees is equal to x over 4. Okay. Multiply both sides by 4, so you'll end up with 4 times tan 42 degrees is equal to x. So then x will make, what? Someone put that in the calculator for me. 3.6. What's the next one after that?
1.
So if you get 3.601 and you're asked to do it to 2 decimal places, you'll write 0. So 3.60. But you still use the same thing. Check the third number. Oh, off the screen here, sorry. Check the third number. Because it's 1, I don't increase that 0. So I just leave it. Okay. So even though it's a 0, you still need to put it in if I'm asking specifically for 2 decimal places. Okie dokie. Last one. So same deal. What's my x going to be in this case? Adjacent. 10. Hypotenuse. So we are looking for a cos. Because adjacent over hypotenuse. Chuck your values in. Cos 24 degrees is equal to x over 10. Okay. Then multiply both sides by 10. So 10 times cos 24 is x. The screen hasn't shut down at all today. Miracle. All right, and then we'll end up with what? 9.14. Thank you very much. So 9.14. Okay. So down the bottom, I've just gone a bit of a reminder, any CAS tips to remember. So if there's anything you want to write down now, just scribble it in there and then you can put into your summary book later. So like, for example, what buttons do I press on the CAS calculator? Control Enter, whatever. Okay. All right. So that is it. So today you are going to work through 3F. Okay. Yes.